Okay, to continue on from the last video, I got shut off at 10 minutes. So we have our y-intercept of 5, and we were about to graph this line at a similar slope, but in a negative direction. That would be something like a negative 2x slope, and that's how we would graph the line y equals negative 2x plus 5. I'm going to, on this next page, give a couple other examples of different, still writing in slope-intercept form, but with different numbers in the place of slope in the y-intercept. So let's do one that's like 3x minus 2. And again, this number here is what tells us how the slope is going to be. And this number here tells us exactly where the line is going to cross at the y-axis. Now we have a minus 2. So this time the line is going to cross in the negative side of the y-axis. It's going to actually cross at negative 2. Okay, you can barely see that. Negative 2. And so we know the line is going to cross through here. But now the next thing we have to think about is the slope of this line. Is it positive or negative? We see that it's positive. It's a positive 3. And so because it's positive, it's going to be some kind of a line that goes, it starts off down below on the left side of the graph, and as it moves towards the right, it moves upwards. Now I need to think though, what is the slope of a 3? When I was showing you examples on the calculator earlier, a slope of 3 is getting steeper and closer to the y-axis. So remember that we want to compare everything to the y equals x graph, which splits both quadrants exactly in half. Well, 3 is going to be steeper than just y equals x, which is the same thing, by the way, as y equals 1 times x. 3 is a bigger number, so a bigger number is going to make this line move closer to the, and make it more vertical and move it closer to the y-axis. So I'm going to guesstimate that my slope of 3 is something like that. Now, I just sketched a graph of y equals 3x minus 2, and just to show how accurate that is when we sketch like that, I'll show you on the calculator. What was the equation again? It was 3x minus 2. When I graph that, that's pretty close to what I have here. It's almost precisely the same steepness. Okay, so it's more, I think it's much more efficient to know slope intuitively, in the sense that you just know about how steep a line is going to be based on the number that you see for slope in your equation. So we're going to do that one more time. Let's try a different equation. Let's try y equals negative 2x plus 10. Okay, so again, if I know that is the number that's going to help me designate the slope of my line on the graph, and this is the number that tells me exactly where the line is going to cross through at the y-axis, then my graph should be, first of all, y-intercept's positive 10, so I'm going to mark 10 spots and I'll move upwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have first of all, I notice on my slope that it's not only a negative 2, but it's a negative slope line. So that means if I were to put my pen down to demonstrate the slope of the line, it's going to be something like that, where it starts off high on the left side of the graph and moves downwards on the right side of the graph. So that's what negative is going to tell me. And then the fact that it's negative 2 means it's going to be a little bit steeper than the y equals x graph, but not much. But because I have to make it negative, I'm going to have to reverse that. So basically I know the line is going to cross through here. That's my y-intercept. And my negative 2 slope is something like that. If I were to sketch it, that's about how I would do it. Now over here, I'm going to graph it again, but this time I'm going to have to change my window, because I noticed that I did my y-intercept at negative 10, and my window is stopping at negative 10, so positive 10. Sorry, my window is stopping at 10 all the way around, so I need to change that. I'm going to change it to y max. Let's make it 20, just to be clear. Okay, now I'll put my graph in, -2 times x plus 10. Okay, and to compare it to this graph here, we'll graph it. That's a pretty good estimate. Now, this graph, the scale is still 1 to 1, but the window is showing more units on the y-axis than my window is. So it looks like my line is crossing through the y-axis at a much higher spot on the y-axis, but really it's not. If you count these little units in here underneath the line, you'll see there's exactly 10, and it does cross through at 10. Okay, so it'd be good if to understand the slope-intercept form of linear equations is to practice by coming up with just different equations, such as, just always put it in this form. Y equals something times x, and then there's a number that goes there, and it's either going to be plus or minus that number. And so you can just practice by just putting in random numbers. You can put even fractions in if you want, or decimal numbers, or whatever, and you can, I don't know, let's put 6x. I'm going to choose minus, and then 8. And then practice guesstimating what your graph is going to be. Oops. By sketching it on paper. And if I know, so I can do this real quickly, 6x minus 8 is going to cross through at -8 on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8. And I know that's a positive 6 is my slope. That 6 is going to be really steep. It's going to be close to this y-axis. Probably even steeper than that. It's hard to draw steep lines crossing it through at a certain point. Maybe something like this. So there's my guesstimate. And then go to your calculator. If you have a graphing calculator, it's really helpful to go and then actually check your guess. Go to the y equals window, clear anything that's there, and then type in your equation exactly as you see it, and then click on the graph button, and then see how it goes. Now, the only thing with the graphing calculator, the window screen is just not great resolution, so when it's drawing a very steep line, it looks jagged and crooked along here, and you can barely see it in the video, but it's really not meant to be. It's just, that's just the way it's just it's the best it can do with the kind of screen that it has. But really what it means is it's a line that's very, very, very steep. It's very close to being vertical, but of course it's not vertical because it never will be, no matter how big that slope gets.